Today we're on pages 24 and 25 of our textbook, and it'd be helpful if you had a graphing calculator. We're going to talk about functions today. A function is any rule that assigns exactly one output value, usually denoted by the variable y, for each input value, usually denoted by the variable x. These rules can be expressed in different ways, the most common being equations, graphs, and tables of values. We call the input variable independent, usually denoted by x, and our output variable dependent, usually denoted by y. Exercise number 1, we have this scenario. An internet music store service offers a plan whereby users pay a monthly fee of $5 and can then download songs for 10 cents each. So we're paying $5 each month, and then depending on how many songs they download, there's an additional charge, plus 10 cents per song per download. Complete the table below for a few different numbers of downloaded songs in a month. So 0 songs downloaded, we just have the $5 monthly charge. 5 songs downloaded at 10 cents each song, so 5 times 0.10 is going to give us 50 cents. So 5 plus 50 cents, or $5.50, would be the monthly charge. 10 songs downloaded at 10 cents each would be $1. So that would be 5 plus $1 is $6. 20 songs downloaded, 10 cents each, $2. So 5 plus 2, 7. B asks us, what are the independent and dependent variables in this scenario? Well, the monthly charge depends on the number of songs downloaded. So the number of songs downloaded are independent and monthly amount charged depends on the number of downloaded songs. So the dependent is the monthly amount charged. Let the number of downloads be represented by the variable x, and the amount charged be represented by y. Write an equation that models y as a function of x. So the monthly amount charged, y, is equal to our $5 plus x times 0.10. Or we can rewrite it as y equals 5 plus 0.10x. Based on the equation from part C, we want to produce a graph of this function for integer values of x over the interval from 0 to 40. Use a calculator table to generate additional coordinate pairs. Okay, so first off, from above, move this down a little bit. The 0 downloads, we're at $5. Let's see, what is our scale here? From 0, we have 1, 2, 3, 4, 5 lines, and we're at $2.50. So divide that by 5, so that means each line here is 50 cents. 25 divided by 5 is 5. Okay, so we have 50, $1, $1.50, $2, $2.50. So next I'm looking at, I want to plot the point 10, $6. So $5.50, $6 would be here. So 10 downloads, $6. 20 downloads, $7. And now using the calculator, I'll key in 5 plus 0.10x, and looking at a table of values, second graph for the table. And let's go out to 40. So I can just hold the arrow down arrow. At 30, we're at $8. 750 is here, $8, and 40, $9. And we do not connect these because we want integer values. If we were to connect, that would include like half a download or a quarter of a download, but it said only integer values. Determining whether or not a graphed relation is a function. Hopefully you recall the vertical line test. The vertical line test, or VLT, is used to determine if a relation is a function. When we draw vertical lines on a graphed relation, a relation is a function if there are no vertical lines that intersect the graph at more than one point. Exercise number 2, one of the following graphs shows a relationship where y is a function of x and one does not. Draw vertical lines. Explain which of these relationships is a function and why. Okay, well, is relationship A a function? No, because the vertical lines we draw here intersected the relation at more than one point. Fails the vertical line test. Relationship B is a function because each one of these vertical lines crosses the graphed relation at only one point. So in explaining, relationship B is a function. It passes the VLT test, vertical line test. It passes VLT. In addition, explanation, for each input, there is only one output. For each input value, I should have said, there is only one output value. Exercise number 3, the graph of the function y equals x squared minus 4x plus 1 is shown below. State the function's y-intercept. Some terminology to know, vocabulary to know here. Y-intercept, that's the y value at which the graph crosses or intersects the y-axis. So the y-intercept, the graph here crosses the y-axis at this point. Its y value is, if there's no scale marked, then the scale is going by ones. So its y value is 1. That's the y-intercept. Between what two consecutive integers does the larger x-intercept lie? X-intercept is where the graph intersects. It's the x value. Where the graph intersects the x-axis. So we have two x-intercepts here, one here and one here. And they asked us for the larger one. So the larger one would be right here, and between what two integers is this? 1, 2, 3, and 4. Between the consecutive integers 3 and 4. C, draw a horizontal line, y equals -2 on the graph. Y equals -2 would be this. Using these two graphs, find all values of x that solve the equation below. We have x squared minus 4x plus 1. This is our graph function. Just label that. This is parabola. And -2 equal -2. So where do these two intersect? That's what it's asking us. They intersect at these 2 points. We want to find the x values that solve this. Well, what are the x values of each of these 2 points? The first one here is 1, -2. And the other point of intersection is 3, -2. We want the x values, 1 and 3. Verify that these values of x are solutions by using the store on your graphing calculator. So remember, 1 store as x, and then x squared minus 4x plus 1. And our result would be -2 if this is correct, which it is. And 3 store as x. Instead of retyping it, I'm just using the up arrow until I'm on my x squared minus 4x plus 1. So I'm like grabbing it, I press enter, it brings it down, and then press enter again. Yep. Equals -2. So it checked.